Hey everybody, it's your faithful friend, and that's about it. Suro 14. Yes, and guess what, ladies and gentlemen? I've decided to keep the name. I might as well just keep it. I mean, I've already put Suro on all the blogs, and I don't want to change it now since I have so many adoring fans. They'd feel bad if I changed my name. But I guess I'll keep it Suro. Now, what's this one going to be about? It's going to be about a bunch of stuff, mainly science! Or, to be more specific, chemistry. But first off, I'd like hear a little something about my life. You may or may not have this at your school if you still go to high school, but my girlfriend went off to Germany for 2 weeks as a school program, and she just came back yesterday, and she had a blast, and I'm really glad she got to go. I mean, I'm happy for her because she got to have a lot of fun and see a lot of amazing sights, but you know, 2 weeks. 2 weeks of a person that's important in your life, I mean, you start to miss them a lot. But I'm glad she's back, and you should have seen her. She conked out right in the car when we got her at the airport. She was tired. She didn't even come to school. The next day on Monday, she was so tired. It was funny. Now, on to chemistry. Yes, folks, I'm a chemistry man. I really do love chemistry, and our chemistry classes are very interesting. Our teacher, he's very unorthodox in the way he teaches, but he teaches some pretty interesting things. I'll give you like just the order of what we've learned in chemistry class. First off, we learned the elements, and in doing so we had to memorize 60 of the elements and put down either the name or the abbreviation. That was a tough one. I failed it the first time, but the second time I got all 60 of them. It was easy. Except I got silver and gold symbols mixed up. They are really hard. I mean, it's easy to get mixed up with those. And next thing we learned was charges, ions and charges. That's always fun. Then chemical equations, net equations. You may not know this. First, balancing equation. That's basically putting chemicals together, elements, compounds, and either finding out what they turn into when they're mixed together, like copper sulfate and ammonium, and that could turn into ammonium plus sulfur, and the copper switches out. Ammonium sulfate, that's an interesting mix actually. And then finding out like net equations, the ionic charges. There's negative charges, positive charges. Ammonium's positive, sulfate is not, it's a negative charge, so those would bond together, and we had to put them down in net equations, net ionic equations, of course. But then we learned about atoms. That's always fun about atoms. We learned how to balance protons and electrons and neutrons and what can go which, and all the different models like Rutherford and his gold foil experiment. I mean, that was always interesting. And now we're going into the light spectrum and wavelengths. Now this has always been interesting to me. To think so much is put in just wavelengths. What we did is we did this experiment where we took a gas, hydrogen, filled it in a glass tube, and then a current ran through it. And using a spectroscope, we got to see what different colors it emits. And let me tell you, every element emits a different color due to the frequency of energy that hits it, like electricity. Like hydrogen gave off, to my eyesight's different for every wavelength. I saw reds, a green, and blue for hydrogen, and nitrogen actually gives off the entire rainbow spectrum. Now think about this for a moment. The colors of someone's shirt is not because of the dye, but when energy bounces off that particular compound, that's what color it emits the most. So think about this. Take a stick of high endurance Old Spice, the color, the plastic red. Alright? It's not just the color of it, like the mix of pigments. It has nothing to do with pigments. It has to do with wavelengths and energy. When energy hits the stick, like light, like infrared light, the color it emits is what our eye perceives. Red. Now that's interesting. It's nothing to do with pigments. The pigments, it's crazy. And then now we're doing wavelengths and finding out like how to calculate different wavelengths. There's Planck's constant equation, which is like 6.626 times 10 to the negative 34th joules times seconds. and then you times that by the different hertz of the other wavelength, and that's how you find its total energy of the total wavelength. It's all crazy equations, but they all go together once you understand it, and it's just amazing to understand. There's so much about chemistry that I just love. Shoot, I may go into game design, but I'd love to get a minor in chemistry. But I'm thinking more on psychology. But maybe if game design doesn't go well, I can always be a chemistry teacher. That always sounds like fun. Well, I'm gonna be signing off. Hope you love my little chemistry thing going on, and give me a shout out about missing people, or just about chemistry. Do you like chemistry? Do you hate chemistry? If you hate chemistry, why? I'd love to know. And that's all. Goodbye, ladies and gentlemen. I'll see you next time.